Hello and welcome to my submission for DES 105. My name is Joseph Wilks and this is my game. So this game is a simplistic recreation of the Cell stage from a 2008 game called Spore. You play as this white cell here and you move around what I consider to be a petri dish in a two-dimensional space. The objective of the game is to simply survive and to devour as many cells as possible so that you can, as a cell, can get as big as possible. And this is done just by colliding with the cells and then eating what they leave behind. Green cells here are after these green plants, like nutrients left behind, whereas red cells and the player's cell are carnivorous and have to kill other cells to collect these red nutrient pieces here. And then, as you can see, your health is represented by the size of your cell. And this sort of goes on forever, or as long as the player can last. It is quite difficult to actually lose this game because once you're bigger than the other carnivorous cells, you sort of just outlast them in a one-on-one fight. Like so. I say fight. It's quite a loose definition of the term. But that's about it. Let's move on to how some of the coding works. So let's take a look at the movement controller script. This is sort of the main workhorse of how most of the game works. And this is attached to both the player cell as well as the NPC cells. There's not much difference between them other than where their inputs come from, and I'll come back to that later. But simply put, movement is more or less controlled almost entirely through something called the destination position. This part here and all this stuff. And this is like I said, this is sort of controlled by inputs, which I'll come back to later. But every update frame, the engine will try to move each cell towards wherever its destination is supposed to be. So we'll move on to now the collision code. This is sort of the other main workhorse part of the game, because there are no rigid bodies being used on these cells. They're all being controlled through straight transformation. There's no forces being applied or anything, and so have to be a bit creative when it comes to collisions. And one of the things that needs to be done is you need to have a bounce effect when two cells collide, and this needs to change depending on which kind of cell is doing the collision. So you'll sort of see here, in the case of two herbivorous cells colliding with each other, they need to bounce off of each other, but they shouldn't deal damage to each other. Whereas if it's a carnivorous cell bumping into the cell that's processing, that cell needs to take damage as well. So they have different parts of the script that they use. This is part of the aggro repel script here. The regular repel script is basically just this bit repeated. The only real other thing of note is that it reduced the health as well as their size. Next, we'll come on to the game thinker script. This is sort of the main brain part of the script. I find that when I tend to do coding, I'm very conscious of creating scripts and processes that would have a lot of things going on in one frame, and this script is very much a symptom of me trying to alleviate that sort of worry. So part one of how this script works is when the game launches, it'll spawn some cells just to start out with, and then it will start a repeating function that basically acts as the AI's this AI in a very inverted commas for the cells. And the way that that thinking works is each of the non-player cells is parented to the same object that has this script, and so the script then goes through each of the child for the game object, goes through each of its children, and it will change its dest position, which I mentioned before. This is where the input stuff comes in. it will change its depth position slightly, so that the cell will then look like it's moving around, sort of at random, admittedly, but it looks more alive than just standing around doing nothing. And since we're talking about inputs, I guess I'll show how player input is dealt, and that's done with the input controller script here. The way this works is it sort of acts as an override to a specified cell object. In this case, it will be the player's cell. It's told specifically that when the mouse button is clicked, that cell needs to have its destination position set to wherever the mouse clicked on the screen. And then it's also set up that if in the future I ever come back to this, I can just quickly create a new event, assign it to a key binding, and make more key binds and actions off of that. So it's sort of a bit of future proofing as well. And then going back to the game thinker, now that we've talked about inputs, another function it has is spawn cell. So it'll the script will randomly spawn cells in the world to keep a population, help keep the game fun, and those cells have a chance of being carnivorous, or they could be herbivorous, and so their color needs to be adjusted on the fly. Well, not on the fly, but at runtime. Related to that, and then there's some other scripts just for cleanup and stuff like that. Next, we'll look at the camera controller. It's a very simple script. It pretty much just finds the midpoint between the player cell's position and the destination of the player cell. This is the only reason I want to do this is because it looks a little bit better than just parenting the camera to the player cell itself. You sort of keep the sense of momentum and the sense of changing direction, which is sort of lost when it's just directly parented. And then we have the two food nutrient globule piece scripts. These are even more simple. They just have a very simple cleanup script here which removes them if they leave the screen, and then a quick script to make the cell that collides with them grow if they match the type. So in the case of the plant cell, the plant food object, if the cell that collides with it is herbivorous, then it will heal the herbivorous cell and make it bigger, and then the same goes for the carnivorous cell. That about does it. That's my my project. I hope you enjoyed. Thank you very much for listening / watching, and thank you for your time.